All right, here we go. This is your favorite math teacher here presenting to you lesson 3.5. Doing this for the first time. This is going to be a four-part lesson, so there's going to be four videos of different lengths, of varying lengths. Really looking at getting to part C. That's really the meat of this lesson and really the meat of the chapter as well. Then we're going to start fairly simple. Talking about stuff we've kind of already talked about before at length. So here we go. This is going to be lesson 3.5, and we're going to end up solving equations using logs and exponential functions. So I'm just going to say just for now, using logs. All right. So this is and this lesson this is part A. Like I said, it's going to be a four-part series, and this is part A. I'm going to first start talking about the domain of logarithms, just because we should. It's not going to help us really solve. It's going to have minimal effect on how we solve equations, but just something that we have to be aware of. We talked about the domain of square roots, of rational functions, and now we're going to talk about the domain of the logarithm. All right, so the parent function, we can talk about the parent function for logs, the most simple, ordinary, straightforward version of a logarithm would just be log, I'll make it a common logarithm, so log base 10 of x. It really doesn't matter what base I use here, just to get us started. And I want to look at the domain of this parent function. Alright, so the domain of this parent function looks like this. It passes through the x-axis there at 1, and it approaches the y-axis, and then it ends up increasing over to the right. So if I wanted to start by talking about the domain of this parent function, it starts at 0 but doesn't touch 0. So I love making intervals on my x-axis. It starts at 0, but we're not going to include 0, and just heads off to the right. So on the x-axis, my domain starts at 0, but doesn't include 0, and heads off to the right. So what we're going to do here in this video is I'm going to look at three different log functions. Here are the graphs. We're going to match up each function to a graph based on the domain that we get for that function. So let's get going here. Alright, so here are my three functions. I'm going to write them across the top here. Log of x squared, log of x over x minus 1, and then log of x squared minus 4. Alright, so I'm just changing what's inside of the log function. And then we're gonna analytically or algebraically come up with the domain of each of these functions, and then based on that domain, match it to its graph. All right. So just like I reviewed with the parent function, all right, this inside part of the function x squared must be greater than 0. Okay. Must be greater than 0. So if we're going to ask ourselves, what values of x make this greater than 0? First of all, when we square a number, it's always positive. So any number that I put in for x is going to be greater than 0. The only thing is that it can't equal 0. So my only restriction to this domain is going to say that x can't be equal to 0. So I'm going to write this domain as negative infinity to 0, but not included, union 0 to positive infinity. All right, and I'm going to wait to match it up to the graph for me to be able to see which graph I'm talking about already. I'm going to wait on that one. All right. All right, so on the second one, again, the inside function must be greater than 0. All right, what I notice here is that inside of the log, now I have something that's in the denominator of a fraction. So my first thought is, oh, first of all, I can't let the denominator equals 0. So I'm going to also say right now that x can't be 1. That's my first restriction. All right, this one's a little bit trickier. Let's talk about when this expression is greater than 0, what I'm going to do, because right now I'm not sure what's going on. Let's do that again. Is make a number line. And I'm going to make a sign chart with this number line. And I'm thinking to myself, all right, what numbers, what values for x is there going to be a sign change at? Let's just investigate. I'm thinking when x is 0, there's going to be a sign change because that's when the top of the fraction is equal to 0. I'm also thinking there might be a sign change around 1 because that's when the bottom of the fraction is equal to 0. So I'm going to investigate here in these different intervals on this sign chart whether the function is positive or negative. All right? So I can do that real easy just by trial and error. So I'm going to take a number from this left interval. I'm just going to use, -1, why not? And see if I get a positive or a negative number. So if I take a -1 and plug it in for x, I get -1, and then -1 minus 1. That's -1 over -2, which is a positive 2. That's greater than 0. It's going to be positive in that interval. All right, when x is 0, the top of the fraction is equal to 0. That means it's just equal to 0. All right, I need more room. Whoa. I need more room. Hold on. There we go. A little more room there. Okay. All right, let's look at this middle interval between 0 and 1. I'm going to just test like 1/2. All right. So when x is 1/2, we're going to have 1/2 on top. 1/2 minus 1 would be -1/2 on the bottom. That's going to be -1, a negative number. All right. So that's not going to be in our domain because again, I want this function to be greater than 0. All right. I'm going to test this last interval. Let's try just plugging in 2 for this last interval. So I plug in 2, I get 2 on top and then 2 minus 1 on the bottom. I can already tell that's going to be equal to 2. All right, that's positive. Interesting. And at 1, remember, that's when the bottom of the fraction is equal to 0. So at 1, it's undefined. All right, so we can write our domain real quick for this guy. I'm going to do it over here. So when is this greater than 0? Well, this interval is greater than 0, and this interval is greater than 0. So my domain is going to be from -infinity to 0, union 1. What is that? Yeah, 1 to infinity. And I'm not including 0, 1 in those two intervals. All right, last one. Finally, let's go for the last one. This one's a little more straightforward. I'm going to use a sign chart again for this one. And again, I want to know when the inside of the log is greater than 0. Let's investigate this. Shucks. Alright, I'm going to do a sign chart again. -2 and 2. Because those are the two numbers that I know in my head make x squared minus 4 equal to 0. So at these two spots, it's equal to 0. Alright, when x is less than -2, like -3, it's going to be -3 squared minus 4. That's 9 minus 4. That's going to be greater than 0. It's going to be positive. I also know that's true for sure for any numbers that are greater than 2. And then inside is where it's negative. All right. So I can come up with that sign chart without doing much work. So my domain is whenever it's positive again. So this is going to be, looks like -infinity to -2, union 2 to infinity. All right. So now that we've got our domains in green, blue, and red, let's see here. So what graph has a domain? What graph has a domain that's everything except 0? Ooh, that's this one. Alright? I'm going to draw an arrow. This is going to be a mess. Draw an arrow. There it is. This is everything except the numbers in between 0 and 1. In between 0 and 1. Ooh, that's this guy. Ooh, yes. And then this guy is everything except the numbers in between -2 and 2. That's the middle graph. Alright, you see how in between here, in between -2 and 2, the graph is not defined. Alright, that's domain. The big thing there is just that inside of the log function, whatever it is, x has to be greater than 0. Alright? That is part 1.